In this example, we want to find the measure of the angle between each pair of vectors. First, we have the vectors I plus j plus k and 2i minus j minus 3k. And then we have the vectors in component form given as 2, 5, 6, and -2, -4, 4. First, we'll find the measure of the angle between the vectors I plus j plus k and 2i minus j minus 3k. For some notational simplicity, we'll refer to the first vector as u and the second vector as v. We know that the cosine of the angle between the vectors, which we'll call theta here, is given by u dot v divided by the magnitude of u and the magnitude of v. So what we need to do here is compute the values in this expression, namely the dot product of u and v, the magnitude of u and the magnitude of v, and then compute the arc cosine of that value to find the angle theta. So we start by taking our dot product of our two given vectors. So here this would be 1 times 2 plus 1 times -1 plus 1 times -3. This would end up being 2 minus 1 minus 3. This would be -2, so our dot product of our vectors is -2. We also need to find the magnitude of these vectors. So magnitude of u will be square root of 1 squared plus 1 squared plus 1 squared, which of course is the square root of 3. And the magnitude of our second vector will be the square root of 2 squared plus -1 squared plus -3 squared. And this will be the square root of 4 plus 1 plus 9, so the square root of 14. So we have all of our values now for our cosine formula. We can then substitute all of those in. So our cosine of our angle will be -2 over the square root of 3 times the square root of 14. And using properties of radicals, this would be -2 over the square root of 42, 3 times 14, inside the radical there. So we find our angle by then taking the arc cosine of this number, -2 over the square root of 42. And when we compute this, we get approximately 1.88 radians, or 108 degrees. So the angle between these two vectors would be 1.88 radians, or 108 degrees. We perform a similar calculation with our second pair of vectors, 2, 5, 6, and -2, -4, 4. Again, we're going to call our first vector u and our second vector v just for notational simplicity. We first have to compute the dot product of u and v. So this will be 2 times -2 plus 5 times -4 plus 6 times 4. So this will be -4 minus 20 plus 24, and we see that that is equal to 0. And actually, at this point, we realize we actually don't need to find the magnitudes of our vectors, because we have the cosine of our angle, which again we'll call theta, will be 0 divided by the magnitudes of our vectors, the product of those magnitudes to be specific. And regardless of what the magnitudes of u and v are, since they're non-zero numbers, the cosine of our angle theta will be 0. And therefore, theta will be the angle whose cosine is 0, and so it'll be pi over 2 radians, or 90 degrees. So the angle between the vectors 2, 5, and 6, and -2, -4, and 4, will be pi over 2 radians, or 90 degrees. Next, we want to find the measure of the angle formed by the vectors A, given in component form as 1, 2, 0, and B, given in component form as 2, 4, 1. You can pause the video and try this example yourself, then resume the video to see the solution in a few seconds. We first find the dot product of the vectors A and B. Here that would be 1 times 2 plus 2 times 4 plus 0 times 1, which ends up being 10. We then compute the magnitudes of the two vectors. The magnitude of vector A is the square root of 1 squared plus 2 squared plus 0 squared, which is the square root of 5. And the magnitude of B will be the square root of 2 squared plus 4 squared plus 1 squared, which is the square root of 21. The cosine of the angle theta between the vectors will then be the dot product divided by the product of the magnitudes. Here that would be 10 over the square root of 5 times the square root of 21, or 10 divided by the square root of 105. We then take the arc cosine of this value to get the angle theta, and so here theta will be the arc cosine of 10 over the square root of 105, which is 0.22 radians, or 12.6 degrees.